Hi everybody, so this video is going to go over Unit 3 Section 1 and Unit 3 Section 2. Both assignments are on Big Ideas Math, so make sure after you watch this you go and you finish both of those assignments. In this video we're going to go over some notes and then we are going to look at some example questions from your homework from 3.1 and 3.2 on Big Ideas Math. So Unit 3 is all about linear functions. Unit 1 basically explains just what is a function. You have to identify whether or not something is a function. Section 2 is going to show you is this or is it not linear. So it's all about Unit 3 is all about linear functions. Section 1 all about is it not a function, or in Section 2 is all about is it or is it not linear. All right, so let's jump into this. Before we get started, there are some vocab words that you need to know throughout this section and also throughout the rest of this chapter. You're going to be seeing these words over and over again. So if you see them on an assignment or on a future quiz or test, make sure you come back to these notes and you can look up what they mean. So you're going to see independent and dependent variable on different graphs that we're going to have. There's actually a few different words that are going to be used throughout this unit, and you need to know like which ones mean the same thing. So for independent variable, what we're basically just talking about is the x values of either whether we're looking at a table or a graph or just a set of points. The independent variables are the x values. You're also here these referred to as the inputs, and you may also refer to them as the domains. So independent variable, x value, input, domain, they're all the same here, and they can be any number. The dependent variable is kind of the flip side of that. This would be your y values. They are also referred to as the output and also the range. So dependent variable, y value, output, range. These are all different terms that mean the exact same thing. So on different problems, on different quizzes, you might see them referred to as different things, but you just need to know that they all mean the same thing. These values are dependent on the value of the independent variable. So the independent variable could be any number, and then depending on what number it is, that's going to determine what the dependent variable will be. But again, just note, independent means your x values, dependent means your y values. So section 1 here for Unit 3 is mainly focused on functions, being able to decide whether or not something is a function or not. The main definition here that will determine this is for every input or every x value, it has exactly one output or y value. So if it is a function, then every x is only going to have one y when we look at them as ordered pairs. If at any point an x value has more than one y value, if say we have x is 3 and y is 2, and then on another point we have x is 3 and y is 7, then that would not be a function, because for a function, every input can only have one output. Next we have the vertical line test. This is a way to see if something is a function when we are just looking at a graph. So let me pull up a graph here with some points just so you can see exactly what I'm talking about. Okay, so if we're looking at this graph here, this is one of the ones from your homework. I'm going to use the left side of this box as my vertical line, and we can give this graph the vertical line test. So the vertical line test works like this. If you pull a vertical line along across a graph, if at any point that vertical line touches 2 points on the graph at the same time, then it is not a function. But if at any time it only touches one, then it is a function. So on this graph here, as we're pulling it around here, you can see it's touching 1 point right here. And as we keep going, there's another point, and there's another point, and there's another point down there, and another point there, And you could see as we pull this across, it only touches one point at a time, and no time does this vertical line right here touch two different points at the same time. Now, if we flip over to this graph here and do the same thing, you could see here it is touching 2 points at the same time. Here again, it's touching 2 points, and here again, it's touching 2 points at the same time. If at any time this vertical line right here is touching 2 points at the same time, then this one is not a function. So again, this one, it was a function because at no point does a vertical line touch 2 points. And for this one, it was not a function because there are 3 different times where a vertical line is going to touch 2 points at the same time. All right, the last two here are just domain and range. These are two parts that a lot of people have trouble remembering. So again, just like I mentioned up here, domain simply means your x values, your inputs, your independent variables. So these are all, make sure you lump these all together as meaning the same thing. Your range is just simply going to be all of your y values. So your dependent variables, your outputs, your y values, that is your range. We'll see more on that later. Okay, so next we are looking at finding the domain and range. This whole section is just going to be about finding domain and range, but there are different types of things that we're going to look at where you are going to be asked to find the domain and range. The first way that it's going to be presented to you is through just coordinates. So we have these what we call ordered pairs. This is your x value -1, comma, this is your y value -6 for this ordered pair. So if we have these are 4 different ordered pairs here. When we list our domain, we are simply going to list each of the x values. So we have, and you always want to list them low to high. So our lowest one was -2. Then we have -1, then we have +2 and +4. So you just list them like this for domain. For range, our lowest one is -6. Now notice we do have -6 twice, but we only write it once. So don't write the same number 2 different times in your domain or your range. You're only going to write it once. So -6 was our lowest one, then we have 8, and then we have 12. So here's our range for this set of points, and here is our domain for this set of points. Again, we were talking before about functions and whether or not something is a function. This one would be a function because for every x value, -1, 2, 4, and -2, there is only one y value. So just because -1 and -2 share a y value, this is still a function because each individual x value only has one y value. Now, if you're looking at a graph and you want to find the domain and the range, you are actually going to write it as an and compound inequality. So we worked with and or compound inequalities in Unit 2, so we're kind of jumping back to this here. When you find the domain of a graph, you're going to write it like this as an and compound inequality. You're going to start with your lowest number in your domain. The lowest number for x is going to be the farthest point to the left. So we see this point here, -4, is the farthest to the left of any of the points. So we write that number first. Then we're going to write a less than sign. It's going to be less than or equal to because this is a closed dot. So remember graphing, if it's a closed dot, it's or equal to. If it's an open dot, then it's just less than. But in this case, it's a closed dot. These are both closed dots, so we're using less than or equal to. So you're going to put your low number, -4. Then you're going to put your x, since it's domain. Domain means your x values. You put another less than or equal to sign, and then you put your high number on the x axis. So if we look at our x-axis, x is the one that goes across. The farthest one to the right is right here, and that is 2. For range, you're going to write it the same way, only it's going to be y in the middle because ranges are y values, and you are going to look for your low number is going to be the lowest point. make sure you don't look at this one. You actually look at the lowest point of the entire line. So here it is going to be 2. You put your less than or equal to sign again because this is a closed dot. You put your y in the middle, another less than or equal to sign, and then if we look, the highest point on this graph would be 6. So our domain, so our for our x values, our domain goes from -4 to +2, and then our range goes from 2 up to 6. So this is how we would write that. Okay, so let's look at a few of the questions from our homework here. So we talked about this would be just a list of ordered pairs, and we're trying to decide whether or not this is a function. And again, if it is a function, it means for every x value, we have 1, 2, 3, 4, and 5 for our x values. There's only one possible y value, and this would be a function. So let's see, is this one also a function? We have 7, 5, 3, 1, and we have 3 again. So on this one, we have the x value 3, but at one point it's 3 and -8, and then at another point it's 3 and 6. So the same x value here, 3, actually is paired with 2 different y values. So this one is not a function. This one again here, we can see that the input, again, remember input x, domain, independent variable, all mean the same thing. So our x here, 2, actually is paired with 2 different y values or 2 different outputs. So again, this one also would not be a function. We also could look at this on a table. And again, here we have 1 as an input, and it is with 2 different outputs. Here it's -1, here it's +1. So again, this one would not be a function. We already looked at this one with the vertical line test. Anytime you're looking at a graph and deciding whether it's a function, just make sure you use that vertical line test like we discussed earlier. You're going to take your line, this is my vertical line on the left side of this box, you're going to drag it across, and if at any point you're touching 2 different points, it is not a function. This one, of course, is a function. So this one here too, if we pull this vertical line across, we could see it's touching the line here and up here at the same time. So it is touching the line at 2 different places. So again, not a function. Let's see. So this is the one that I did earlier in the graph. So let's jump to this one. Again, we're trying to find domain and range. Again, if it's an actual line, then like I showed you earlier, you're going to write it like an and compound inequality. But if you're just looking at points, then you have to figure out what each of these ordered pairs would be. So this ordered pair here would be, let's see, we're 1, 2, -2 on the x, and 1, 2, 3 on the y. So -2 in the domain and 3 on the range. This one here is actually 0 on the x, so we can mark that for domain, but it's also at 3 on the y. Again, we're not going to mark it twice, we only have to mark it once. Our other ones here, this is now +2, and this is now +4. Remember to always hit your check answer button just to make sure you are correct on all of these. All right, so that's all we had for section 1. So let's go ahead and move on to section 2 of unit 3. This one, like I mentioned earlier, is going to be looking more at whether or not things are a linear function. We already learned what a function was. Now we're going to see, is this a linear function? So there's a few different ways that we could look at this. First of all, just to understand what a linear function is, this is an equation that can be written in the form y equals mx plus b. You really are going to want to memorize this equation, y equals mx plus b, until you have it memorized. I would definitely recommend writing it down on a sheet of paper and leaving it next to your computer, because this is going to show up in the next few units that we do. So you are going to have to know this equation, y equals mx plus b. Now in this equation, we have our y value, we have our x value. These are going to change depending on what points we're looking at. The m is going to be for your slope, and then your b is going to be your y-intercept. So when we're looking at different lines on a graph and we put them into this equation, it's going to be y equals whatever your slope is, x plus whatever your y-intercept is. So you're always going to start with this equation, and then you are going to plug different numbers into this equation based on what your slope is and based on what your y-intercept is. So again, if you don't know what slope means, we do talk about slope a lot, and we will talk about it a lot more in the upcoming chapters that we're going to have. So you definitely need to know what slope is. Slope is simply the steepness of a graph. So if we, for example, take a look at this graph here. So if we look at this graph here, you could see just how steep this line is right here. It's the angle of the graph itself. Something that has a really big steepness is going to have a kind of a higher slope, a bigger number. Something that's more flat will have a lower number for slope. Another thing that you're not going to need to know for this section, but you will need to know down the road, so it's something to kind of try to get put in your head. If this line goes up and to the right, it will be a positive slope like this one here. If the line goes down and to the right, that will be a negative slope. So your y-intercept is the place that the line actually crosses the y-axis. So if we're looking at this graph here, the same one we just looked at a minute ago, the y-intercept here is at negative 3. So start with your origin, -1, -2, -3. So this line crosses the y-axis at -3. So if you were asked what is the y-intercept of this line here, you would say -3. Two more things that you're going to see in the homework. It's going to ask you about whether or not something is discrete domain or continuous domain. So the difference there is a discrete domain is when the x values can be whole numbers, can only be whole numbers. So the x values are only going to be 1, 2, 3, 4, 5, just the whole numbers. They could also be negative, -1, 2, 3. But they're just going to be whole numbers. You're not going to see any decimals or fractions or anything like that. When you're looking at it on a graph, it's going to be shown as individual points. So it's not going to be a line, it's actually going to just simply be individual points on the graph. So if let me pull up this one here. So this one here would be discrete because we're just looking at your x values here at -2, 0, +2, and 4. So that's it, just these points. So this would be discrete. Now the other side of that would be continuous domain. So continuous domain is when the x values are all the rational numbers that are in between those whole numbers as well. And this is going to be shown on a graph as a line. So if we look at this one here, this one would be discrete because it's shown as a line. So not only is the x values -4, -3, and -2, it's also all of the numbers that exist in between each of these. So it's -2, it's also -2.5, it's also -2 3/4, it's also -3.826. Any number that is in between all of these are also part of this graph. That's why it's shown as a line rather than just points. So that would be continuous. Think of the line as being continuous. As opposed to just the points. So the points would be discrete domain. They're only talking about the whole numbers. Continuous domain is all of the ones in between. Okay, so like I mentioned earlier, section 2 is just all about telling us, is this linear or nonlinear? So there's a few different things they're going to have you look at, and then you are going to have to decide if it is linear or nonlinear. So one way that we're going to do this is it's going to have you looking at different graphs, and you have to decide, is this a linear graph or is it a nonlinear graph? Well, when you're looking at graph, that's actually the easiest to tell whether or not something is linear or nonlinear, because linear means line. So if it is a straight line, then it is a linear graph. If it in any way curves like this one does, or it takes a sharp turn like this one does, this one also is a little curvy. These are non-linear. They're not lines. Okay, they are curved or they're an angle. So a line, linear, just simply means it's a line. It's a straight line. So if you see a graph and it's a straight line, it's linear. If there's any type of curviness to it, or it has a sharp angle to it, it takes a turn, it's not just straight one direction the whole way, then that is non-linear. All right, another way we look at deciding whether or not something is linear or nonlinear, sometimes rather than a graph, you're going to be presented with a table like this here. This is called a table. We have our x values here, also called our domains or our inputs, and then we have our y values, also called our range or our outputs. To decide whether or not it is linear or nonlinear, you simply have to look and see when this goes up or maybe it goes down, does it do it consistently? So consistent means the same every time. So as we go from the first one to the second one here, we went up one. We went up one again. We went up one again. So the x values are good. They are consistent. But you also have to look at the y values. They both have to be consistent for a table to be considered linear. On this one here, it goes up 5 and 5 again and 5 again. So this one here is linear. Both the x and the y go up consistently. If we look down at this one, for our x values, it goes up 2 and 2 again and 2 again. So we're good on the x. But if we look at the y here, we go from -9 to -3. That's a change of +6. Then we go from -3 to -1. That's only a change of +2. Then we go from -1 to 3. That's actually +4. So the y is not changing consistently here. Therefore, this table does not represent a linear function. This would be non-linear. If we looked at this, if we actually plotted these points on a graph, 1, 5, 2, 10, 3, 15, 4, 20, if we plotted these points on a graph, it would end up creating a straight line. If we plotted these points on a graph, it would not end up a straight line. We would end up with a curve. Okay, so the last one here, and this is probably the most difficult to kind of figure out, but there is kind of a shortcut to do it that I'll explain after I give you this explanation here. So a linear equation is one that could be written in the format y equals mx plus b. Again, where m is your slope and b is your y-intercept. So in this example here, y equals 3x plus 2. So here your m equals 3 and your b equals 2. It is in the same format, y equals something x plus or minus something. It could be either or. If your y-intercept is below the x-axis, it's a negative. It would be, you'll see it as minus the number. Here, the y-intercept is plus 2, so plus 3x plus 2. So when it's written like this, it's real easy to tell. You could see this is the same as this up here. So that's a lot easier to tell, but it's not always going to be that simple. Sometimes they're going to kind of mess with the equation and move stuff around and add other numbers in there. You just have to be able to recognize that with algebra, we can change this equation here to make it this. So I explained how to do that down here, but it'll probably be a little easier to understand if I just use my paint pad here. So okay, so on this here, this was the equation I gave you, and you're trying to figure out, is this a linear equation? Can we put it into the format of y equals mx plus b? So can we get this into this format? And we certainly can. We just have to use a little algebra, jump back to unit 1 where we talked about how you can manipulate equations to solve for either y or x. So basically what we're doing here is we're solving for y, because as you can see here, it's y equals. So we need to solve here for y. So we want to get y by itself on one side of the equation. Remember, if you do the same thing to the left side that you do to the right side, it all will work out the same. So here we have a minus 9, so if we add 9 to both sides, leaves us 3y on this side because these 9's minus 9 plus 9 cancel out. That leaves us with 12x plus 9. Now notice 12x and 9 are not like terms, so we can't add them together. They just remain separate on the right side of the equation. Now if we look at this, we're a lot closer to what this looks like. The only problem is there's a number attached to our y. We're going to need to get rid of that. So it's 3 times y, so we're going to divide by 3. Now we need to divide everything on this right side by 3. And now these will cancel out, leaving us y equals 12 divided by 3 is 4x. And then 9 divided by 3 is 3. So now it is y equals 4x plus 3. So you might in the future see some problems where it'll give you an equation like this and it'll say you need to write this in what we call slope intercept form. This is slope intercept form. This is the format that it needs to be for a linear equation. So that is what you would have to do to get to that. All right, but there is an easier way to do this. So there's certain things that sometimes you'll see in an equation where you'll just immediately be able to recognize this is not a linear equation. So here's a few of those examples. If you ever see a square root sign over one of your variables, you will immediately know that this is not a linear equation. If you ever see an exponent over one of your variables, again, that means immediately you should know it is not a linear equation. Also, if there's a third variable in the equation, y equals x plus 6z, we have a third variable thrown in here. Again, you know it is definitely not a linear equation here. So if any of these 3 situations pop up, it is not a linear equation. If you don't see any of these 3 things, it probably is a linear equation. You might have to work it out a little bit like we did here just to make sure, but you can pretty much assume that it is going to be a linear equation if you don't see a square root sign, an exponent, or an extra variable thrown in. All right, now that is it for that. So let's go ahead and look at some of the problems that we had on the 3.2 assignment. Again, when we're deciding is something linear or nonlinear, if we see it isn't a line, it's curvy. So we know that when it's not, this is linear, it's a line. It goes just continuously in one direction, continuously in the opposite direction. That is a line. It's completely straight. Again, linear. Again, linear. And this one would not be linear because it has that turn in it. Again, not linear. When we're looking at tables, this was the same one I used in your notes, and this is the other one that I used in your notes. So let's take a look at this one just as another example. Here we go up 4, here we go up 4 again, here we go up 4 again. So we know x's are good. Here we go down 4, then we go down 5, then we go down 6. So no, this one is not a linear function. So let's take a look at this one. I always kind of hate these because it shows you a wrong example and then wants you to correct the example. And I think these kind of confuse kids more than really helps them out. So in this question, I'll just go ahead and show you the answer here. The error here is that this person thought, oh, because it's times 4 consistently, then it is a function, and that is wrong. When we're looking at function, we're only looking at subtraction or addition. So here we are adding, 12, and then here we are adding 48. So that is not consistent. It needs to go up or down through addition or subtraction consistently. Just because it's multiplied by 4 each time does not mean it is consistent. So the function is nonlinear, and the increase in y is not consistent. So that would be your answer there. All right, again, you see the exponent here, so you know immediately this is not linear. Here, just because these are flipped over, you could rewrite this as y equals negative 3x plus 7, and that is our y equals mx plus b form. Here again, I mean, there's a lot of stuff to work out. I'm not gonna work it out for you. Just take my word on it. What I said before, you don't see any square root signs. You don't see any exponents. There's no variables that aren't x or y. There's not a third variable thrown in. So you can manipulate this into eventually being that y equals mx plus b. So this one would be a function. Same thing here. If you just kind of move some things around, it will be a function. All right, so that's all we have for today. This is actually a throwback to the 3.1 homework, so should already know how to answer that. So that's all we have for today. Go and make sure you finish up your 3.1 and 3.2 homework. If you finish the 3.2 by Friday at the beginning of class, you get that X credit. So get that X credit, get your stuff turned in on time. If you have any questions about anything, make sure you let me know, and I will see you all tomorrow.